Let's take a look at some of the common questions from 3.4. These are all about solving equations involving logarithms. So first one here, log base x of 625 equals 4. What I would do is rewrite this thing as an exponential. I think that's the best way to go. So x to the fourth would equal 625. Now if you know something right away to the fourth power that equals 625, then you know what to put here. If you don't, what I recommend is go ahead and break down the number you're looking at. Let's see if we can make this something to a power, and then we can maybe play around with the exponents and figure it out from there. So 625, if you don't know that this is 25 squared, you could divide by 5 and see what you get, kind of chip away at it. But that'll become 5 times 5, and then eventually 5 to the fourth power. So 625 is 5 to the fourth power. So what I'm going to do next is rewrite it that way. 625 is 5 to the fourth. And now since both of these are to the fourth power, then x has to be 5 to make that balanced out. That's probably the easiest approach to take on this one. 67's got a lot of pieces going on. Ultimately, the variable we're looking for is part of an exponent, and that tells us we're going to have to take a logarithm to get this figured out. So I think what I would do right away is go ahead and put this part together. Since there's no variable inside here, let's just go ahead and add that. That's going to be 1.0083 repeated, and it's going to be to the 12th power, or 12t. Now at this stage, we've got this number to the 12t equals 2. It'd be really nice to take a log maybe and make, since the variable is going to be an exponent, but we're going to have to take a logarithm. So if I took the correct log here, I could make this piece go away. So that's the way you really want to go. Take the log with this base, which is a really weird base, but it's going to get the job done. So I want to do that on the other side as well. So I'll see if I can bump that 2 out of the way, or just scoot it over. Let's do this. There we go. So log base 1.0083 repeated of 2. So what I'm doing is I'm taking that log of both sides, and that's okay as long as I do it to both sides. Well, that washes out. 12t is all that's left. And you can just, for now, we'll just leave it like that. You can always put it in the calculator. The book tells you can round to 3 decimal places. Exact answers are always acceptable on tests and quizzes, so even if I tell you to use a calculator, a lot of people will end up just giving me the exact answer, and I'm good with that. So we're almost done. We're just about by 12, and that's going to give us t. And as a decimal, let's put it in the calculator so you see how that goes. I'll just do one of these in the calculator, and this will see if your answer matches what the book has. So again, it's alpha and window. Pick option 5 for log base. This was log base 1.0083 repeated. Now we can't, there's no repeat button on the calculator, so just put a bunch of 3s, not a very specific number, but I think about probably 10 should definitely tell the calculator this is repeated. It may even go into like a mode where it detects that. Either way, that should be good to go. And log, we're taking out 2, and we're going to divide that whole thing by 12. So there's your decimal answer, 6.96. Okay, so for 69, again, a lot of pieces. Ultimately, the variable is an exponent, so we're going to need to take a logarithm to get that taken care of. I would approach this as I would approach any equation. Let's start with the order of operations. We've got some parentheses, so they'll be left for last. We do have something times what's in parentheses, so let's divide that off first. So divide both sides by 5,000. And that's going to end up being 50 on that side. So 1 plus point, and I'll tell you what, while we're at it, let's go ahead and add these two things together. So 1 plus 0.005, 1.005. Still to the x power, still over 0.005, and that's going to equal 50. When you divide these two, you get 50. So now, I've dropped my parentheses because this is all this was in parentheses. So I've got an exponent going on, I've got some division. So we got to take care of division first. So let's do that. Multiply by 0.005 on both sides. And I'm okay with you putting this in the calculator. That's going to be 0.25. And 1.005 to the x still on this side. Really the same trick we just used on the last problem. Take the log of this base to get x by itself. And we'll do it on both sides. So log base 1.005, and do it on both sides. That's probably not looking good, but anyway, that's the idea. Take log base 1.005 of 0.25, and that'll give you your answer. And I'm fine for now, just leaving it that way. So let me write that a little nicer. Log base 1.005 of 0.25. And again, you put it in the calculator, I think it was like negative 277 point something. But that's good for now. You can leave it that way. These are always fun. This is a skill you need from, or you need to be pretty good at when you get to calculus for something called a chain rule. And that's looking for a U substitution. Anytime you have a trinomial, but it's not something squared, something to just a normal first power, you want to be looking for a U substitution. And ultimately what we want is for this thing to be in the form u squared minus 4u minus 5. Basically I'm keeping my coefficients the same. 4 and a 5, any number, coefficient or constant stays the same. But the part that's raised to a power, I want that to just be squared, and I just want it to be the first power. So we need to come up with a u that's going to make that happen. Usually it's just the middle term. Sometimes you have to do a little bit more to it, but let's see if that works. And when I say middle term, I mean the variable piece that's raised to an exponent for the middle term. So if u is e to the x, and I plug e to the x in here, that looks good. If I plug e to the x in here and square it, well, e to the x squared, we know that exponent raised to an exponent, the exponents multiply. So that would be the same as e to the 2x, which looks like this. So that's what I want to use for my u substitution. So I factor this like I normally would. That'd be u minus 5, u plus 1. Keep in mind it is an equation. Keep that there. I've seen equal signs magically disappear. I've also seen them magically reappear or just come out of nowhere and appear. So just, if it's an equation, you got to solve it. If it's not an equation, don't turn it into one. So just keep that in mind. With this one we do need to solve. So u would equal 5. U would also equal negative 1. But we didn't have u in the beginning, we were solving for x, so we need to get that back in. So u is e to the x. Now we substitute back in. And let's solve for x. So to solve for x, we're going to take the log of both sides, take a natural log. Natural log undoes e. So if we take, or just rewrite it. Log base e of 5 is x, which is natural log. Okay, so there's one solution. And on the other side, log base e of negative 1, the natural log of negative 1 would equal x. Should be recognizing that's a problem now, because there is no power of x we can, or no power of anything we can raise a number to that it comes out to be a negative. So therefore you can't take the log of a negative or 0. So this is impossible. This part can't be done. So that's not a solution. The only solution is log 5. I think what happens on this one is after I do that last example, a lot of people get kind of entrenched in that u substitution zone, which sometimes that's the way to go, but on this one, they're both e raised to something. Since they have the same base, we just need to make sure these exponents are equal to each other. So let's just go that route. X squared minus 3x needs to equal x minus 2. And it's an equation. We're trying to solve for x, so having a second degree, having any degree more than first power, you need to get everything equal to 0, and you need to solve it. So x squared, I'm going to subtract an x, and I'm going to add the 2, and that's going to equal 0. Now if you try to factor this, you're not going to get very far. The only factors of 2 are 2 and 1. They don't add up to negative 4, so there's no way to make that work. This is going to be a candidate for quadratic formula. So I'll just kind of get you started on that, and then I'll stop there. So negative b plus or minus the square root b squared minus 4ac all over 2a. And then solve that down, and that'll give you your answers. Okay, 109, I did something similar to this in the examples. A lot of times it still gives students trouble, so I figured I'd go through it. I'm going to go ahead and leave the left side the same for now, but check out the right side. There's something that should be popping out to you at this point. So I'm going to say something I've said quite a few times now, and I'm going to continue saying it all throughout the chapter, and hopefully you never forget it because you heard it so many times and you just got tired of hearing it. Logarithms are exponents. If exponents are getting subtracted, then the big numbers had to have been divided by each other. So we can condense this to log of x minus 1 divided by x plus 1. Let's say that the other way. If these two things are getting divided, their exponents got subtracted. Logarithms are exponents, so the logarithms would have been subtracted. And that's what we're seeing. So if we go the opposite way, we get to here. So now we've got this situation pretty similar to the last one I just talked about. We're taking natural log of both sides. If the thing we're taking natural log of is equal on both sides, we can solve for x. So we can basically drop the natural log. Now, if you don't like that idea, it feels like magic, just take both of these, make them base e, and raise them to this power. And that might seem even weirder, but that's a way you can algebraically cancel out the natural log. Because whatever you do to both, as long as you do it to both sides, you can actually create, make this a power, and you could say 2 to that power as long as you do it on both sides. That's okay. So x plus 1, we'll multiply by that, so it goes away over here. And what that means on this left side is that we get x squared plus x plus 5x and plus 6x, and then plus 5, sorry. And then we're left with x minus 1 on this side. So the same deal I mentioned before, we got x squared, so everything's got to get on one side. So that equals 0, so x squared plus 5x plus 6 is 0. So I need x plus 2, x plus 3 equals 0. And if we solve that, x is going to be negative 2, and x is going to be negative 3. Now, no matter how far you go in math, if you're solving an equation, don't ever forget to check your answers. So let's try both of these. If x is negative 2, plug it in here, take log 3, seems all right. Plug it in here, take log of negative 3. All right, that should stand out to you. That can't be done. Same deal with the negative 3 here. That also can't be done. So the two things that could have been solutions, neither one are. So that tells us right away we're not going to get a solution. So there's no solution. Something else you can do in the beginning, a little less popular, but some people prefer it. Check your domains. Your domain for this piece, x would have to be bigger than negative 5. For this piece, x would have to be bigger than 1. And for this piece, x would have to be bigger than negative 1. Now, to work, your x value has to be able to plug into all three places. So if it fails on any of these conditions, we've got a problem. If you kind of think how a number line, how this would look, it'd be everything from negative 5 on, everything from 1 on, and everything from negative 1 on. And it has to fit every condition, so this part and this part and this part. So really the only thing that works is anything that's bigger than 1. So your final domain, x has to be greater than 1. And if you do that right in the beginning, as you get to your final solutions, you can know right away that neither one are bigger than 1, so we're done. Neither of these work.